All right, so this is the second video on factoring special expressions. The first video was on perfect square trinomials, and this one's on the difference of squares, okay? So, everything you need to know is right in the name here. Difference means we're going to have a subtraction. Squares means it has to be a subtraction of two different perfect squares, all right? So, in the initial video, we introduced these perfect squares. These are the first 12 numeric perfect squares, okay? 1 squared is 1, 2 squared is 4, and so on, up until 12 squared is 144. Okay, so you should really have these first 12 memorized. It's not bad to go on up to 15. So 13 squared would be 169, 14 squared would be 196, and 15 squared would be 225. Okay, so memorizing those first 15 is a great idea. With the variable expressions, again, remember from the previous video, if you've got an even exponent, then that variable expression is a perfect square, okay? As you can tell from the pattern we established here, okay? So let's go down to the difference of squares problems here. Again, just like with perfect square trinomials, recognition is the key. So what you're asked to factor will always be a binomial, okay, with one positive term and one negative term, all right? Now, just to show you how these factors come about, if we were to multiply these two binomials using either the FOIL method or the distributive property, however you want to think about that, okay? When I multiply x plus 5 times x minus 5, I get this first, and then notice here in the middle, the two like terms are opposites of each other, so they're going to cancel out, okay? So when I multiply x plus 5 times x minus 5, I get x squared minus 25, okay? So again, notice here, a binomial with one positive term, x squared, and one negative term, negative 25, okay? So these are both perfect squares. They're separated by a minus sign. It creates what we call difference of squares, and when I factor this, my answer would be x plus 5, x minus 5, okay? So let's kind of look and see what's going on here. The square root of x squared is x, so notice the first term in each binomial is x. The square root of 25 is 5, so the second term in each binomial is 5, and then those binomials are going to have a plus sign in the first one and a negative sign in the second one, okay? This one's a little more complicated. We've got 2x plus 3 times 2x minus 3, okay? So when I use FOIL method or distributive property, again, notice what happens in the middle. Those middle terms, they're like terms, they cancel out. They're opposites. Positive 6x and negative 6x cancels out. So 4x squared minus 9, these are both perfect squares, okay? They're separated by a minus sign, so I recognize that I have a difference of squares, okay? So when I factor this, the answer is going to look like what we started with, okay? Square root of 4x squared is 2x, so notice that's the first term in each binomial. Square root of 9 is 3. Notice that's the second term in each binomial. And then we're going to have one plus sign in between the two and one negative sign in between the two, okay? So, factoring difference of squares. When you have a squared expression subtracted from another squared expression, like we do here and here, okay, then you have what's called a difference of squares. It can be factored using the property below. So, take the square root of a squared, we get a and a. Take the square root of b squared, we get b and b. And then I'm going to alternate the signs in here. And that's going to create this canceling out like happened in our examples up here, okay? So without these signs being different, these terms wouldn't cancel out. If these signs were the same, then that would make it a perfect square trinomial, and that's not what we're dealing with here, okay? So, number 5, question for yourself. Is x squared a perfect square? Yes. Is 49 a perfect square? Yes. Are they separated by a minus sign? Yes. So this is a difference of two perfect squares. So how am I going to factor that? Well, square root of x squared is x. Square root of 49 is 7. So my factors are going to be x plus 7 and x minus 7. And that's my answer. There's nothing else I can do here. Okay? Let's try the next one over here. Y squared minus 121. Are they both perfect squares? Are they separated by a minus sign? The answer to both those questions is yes, okay? So that means this is a difference of squares. So my answer is going to be y plus 11, y minus 11, okay? Let's look at number 6 and number 8 here. I want you to pause the video here, try both of those, and then come back and check your work. Okay, are both of these perfect squares? And the answer is yes. This is 2t times 2t. This is 9 times 9. They're separated by a minus sign. So my answer is going to be 2t plus 9 and 2t minus 9. Okay? And in the last example here, these are not perfect squares. Okay? 18 is not a perfect square. 50 is not a perfect square. Okay? But that doesn't mean I don't have difference of squares here. If you'll notice, I can take out a greatest common factor. These are both even coefficients, even numbers, so I can divide those by 2. Okay? Well, what that leaves inside is a 9a squared here and a 25 here. So 2 times the quantity 9a squared minus 25. Now, question you need to ask yourself, is this a difference of squares? And the answer is yes. Square root of 9a squared is 3a. Square root of 25 is 5. So when I factor that, the 2 is going to stay there. And then my other factors, my factors for this perfect square, difference of squares binomial here is going to be 3a plus 5, 3a minus 5. So this would be the answer, the complete factorization for this binomial, okay? And that's how you factor difference of squares.